Hi everyone, Mrs. Bilo here. In this video I'm going to be going over the Chapter 9 notes, slide 6. This is an introduction to one of our main focuses for Chapter 9, which is stoichiometry. Chapter 9 is very similar to Chapter 3, in which you will be converting grams to moles and moles to grams, but now we're just adding one other step, and this is that one other step. This is that extra piece, something that's new that you haven't seen before. The other skills though that are in this chapter you have seen before. We're just going to be using them in a different way. So for this question here, we have a chemical reaction. Remember, the reactants are on the left-hand side of the equation. Those are what react. And the products are on the right-hand side of the equation. That's what gets produced at the end of a chemical reaction. So in a spacecraft, lithium hydroxide, which is this, LiOH, that's an ionic compound, is used to absorb carbon dioxide, which is CO2, that is breathed out by astronauts. And then these are the results of that reaction. So we have, of course, water, and then we have lithium carbonate. So the question is, how many moles of LiOH, so that's what we're trying to find, so that's what we want our final answer to be in, are required to react with 20 moles of carbon dioxide? So ultimately we're going to be doing a picket fence, but before we get to that, I'm going to balance this chemical equation. So we have, let's start with the carbon first. There's one carbon here and one carbon here. That's good. We have the same amount on either side. Let's look at the lithium. There's one lithium here, but there's two lithiums here. So to make them the same on either side, I'm going to put a 2 in the front. When you come across an equation where you're seeing a lot of oxygens and hydrogens, like I'm seeing in this one, you typically want to balance those last. And this is the technique that I use. I go back and forth. If you do need to tally everything up, you can do that. You could say like one carbon on this side, one carbon on this side. We had 2 lithium on this side, we had 1 lithium on this side, but then we put the 2 in the front, so that changed it to a 2. You can use that method as well. I'm just going to go back and forth. So now I'm going to look at the oxygens and the hydrogens. So let's start with the hydrogen. So because I put this 2 in the front here, that 2 also gets applied to this one hydrogen here. So this right here, that's 2 hydrogens on the left-hand side. And then it looks like I already have 2 on this side, which is good. So the hydrogens are balanced. And then next I'm going to look at oxygen. So you can see that there's 2 oxygens here. And then there's 4 oxygens here because this 2 gets applied to everything that it's in front of. So there's 2 oxygens, that's a total of 4 oxygens. And then over here, I can see there are 3 oxygens here, and there's 1 here, that is also a total of 4 oxygens. So this chemical equation is balanced. Again, you can leave these blank or you can put 1s in the front. I'm going to put 1s in the front because that'll be easier for teaching you this concept. So essentially what I just did was I put those numbers in the front to balance the chemical equation. Kind of like this example. This is another example here. Those numbers in the front, they are called coefficients. And again, that's to balance the chemical equation so we can obey the law of conservation. Matter cannot be created or destroyed. However, those numbers also represent moles, and they can also represent what we call mole ratios or mole to mole ratios. So for example, if you're looking at this equation here, this is how water is made by combining hydrogen gas with oxygen gas to make water. When you're doing that, you would want to combine hydrogen and oxygen in a 2-to-1 ratio. You want 2 times the amount of hydrogen in comparison to oxygen, or 2 moles of hydrogen for every 1 oxygen, to produce 2 moles of water. This is really important because, especially for chemists, if you want to get like the maximum yield and not waste anything, you want to look at these ratios. Because if you only had, like, let's say 1 mole of hydrogen here, well, then you're not going to be able to make as much product as you would like. So this is the new concept that we're introducing, which is stoichiometry. So again, most of you know how to do moles to grams and grams to moles, and convert between atoms and molecules as well. So using your periodic table to find molar mass and using Avogadro's number. However, up until this point, we've only been, with those questions you've only have worked with one type of substance in that problem. This time we're going to be working with 2 different substances. And that's why we need the balanced chemical equation. This balanced chemical equation is going to tell us the relationship between 2 different things. Literally, like stoichiometry, that comes from a Greek word, stoichion meaning element and metron meaning measure. So with stoichiometry, we're looking at the relationship between the reactants and the products in a chemical reaction. And based on that relationship, that ratio, we can convert between those 2 different things. So going back to this problem here, I have the balanced chemical equation. And now I'm going to start my picket fence with what I was given, 20 moles. And what's really important moving forward is you don't just write 20 moles. You have to write 20 moles of whatever substance it is that you're talking about. So in this case, 20 moles of CO2, which is carbon dioxide. So if I have that many moles, how many moles of lithium hydroxide will I need? Now, most of you know, like, based on what I was talking about previously, I would double it, but let me show you how else you could figure that out in a picket fence. So if I have moles of CO2 here, I know moles of CO2 has to go here in the bottom. Now, where do I get this number that goes here? Well, I'm going to get that from the balanced chemical equation. So 1 mole of CO2, that's coming from the balanced equation. And then on top, what that is equal to, or the ratio that that's equal to, that I'm trying to convert into, I'm trying to convert into moles of LiOH, which is lithium hydroxide. And that number is also going to come from the balanced chemical equation. These units cancel, so I'm just left with moles of lithium hydroxide. I multiply the 2 numbers in the top, divide by the bottom number, so 20 times 2 is 40, divided by 1 is still 40 moles of LiOH, and that would be your final answer.